Alright, welcome back to day 9. I can't believe we've been doing this for 9 days consistently without breaking the chain. In today's video, I'm going to be solving a different problem. In the past videos, I've been solving hacker rank problems. Today, I decided to jump to neat code again, and I found everything I was doing here before. I used to do it in the practice tab here, neat code all or neat code 150. And I was going as I think he changed this. Oops, no, that's not what I wanted. Here we go. This is what I was looking for. Yeah, this is kind of like the problems I was working on right before starting on HackerRank. So today I just decided to go back at it and do it. Last time I solved a problem for LeetCode was 7 months ago. I try to understand all the problems I work on, so that's why I always have like a Jupyter notebook and try to dissect the problem instead of like blindly attempting the problem, which is optimal for a interview setting that I would be facing at some point. But also my process of learning, as I have mentioned before, it's focusing on breadth first, where I just try to go over every single topic and then I'm going to go depth, right? I'm trying to familiarize myself with all the data structures and algorithms before I really just go diving deeper into the topics, right? So I'm not trying to master anything right now. I'm just trying to learn, and yeah, that's just a little bit of what we're gonna be doing. Thanks for being here, and let's go ahead and get the problem started. So the problem is, I was a little, I don't know, not scared, but what's the word I'm looking for? Can't find it right now, but basically I was trying to kind of backtrack of this problem because it's a medium, this one right here, the following one, and I was like, I don't know if I should just go ahead and jump on this, but yeah, I mean, eventually we have to get there. I remember solving group anagrams a while ago, but I just decided to go ahead and do it, and we'll find the solution together. It's not going to be anything out of this world. I probably would have to go to many iterations. I don't think it's going to be as crazy as I'm thinking, probably, because we're going to count frequencies, right? We know which data structure, at least on my level, I think I need, right, which is a hash table, a hash map, to count those frequencies, and based on that, I can proceed. I guess I should read the problem first, for those who don't know or haven't figured out this problem. But if you ever make it here, just know that hash tables are going to be very important at this stage. So basically, the problem says given an integer array of nums or numbers and an integer k, wow, return the k most frequent elements. You might return the answer in any order. Okay, I'm gonna read that again because, man, that was rough. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. All right. And then we have the first example here, which is an array of 1, 1, 1, 2, 2, and 3. Is saying that we have to return the 2 elements k that are most frequent in that list, which are 1 that repeats itself 3 times, and then 2 that repeats itself twice, right? And the second example, we just have an array of 1 number, and we're looking for that only number, and then that's it. That's like a straightforward one. Constraints, we're going to be dealing with an array of, well, all the numbers. So 1 is less or equal to nums ln 10 to the power of 5 minus 4. Okay, so we could be dealing with negative numbers. So the array is going to be all the way from one item all the way up to 10 to the power of 5. So it could be a possible large array. And also the numbers in that array are going to be anywhere from minus 10 to the power of 4 to 10 to the power of 4. So big numbers, or large numbers, I would say, considering the type of data we're going to be manipulating, right? Which is just numbers, array of numbers. K is in the range 1, the number of unique elements in the array. K is in the range of 1, the number of unique elements in the array. Okay. It is guaranteed that the answer is unique. Okay. And then a follow-up question. Your algorithm's time complexity must be better than big of n log n, where n is the array's size. Okay. That's what I like about LeetCode a little bit, is the fact that you always get follow-up questions, and you get to practice. Like, once you think you have a solution, then and you're looking for a more optimal solution, you can check the follow-ups, and it would give you a little more of, gas to think about it, if you, so to speak. Just something extra for you to try to improve, like a little hint, I would say. So anyways, let's go ahead. I'm gonna go ahead and maybe come here. I don't want to jump straight into coding. I got all my tools here trying to save time, because I always open all these things while I'm recording the video. But for the sake of time, I was just like, I know I'm already gonna visualize the code, and I also know that I'm gonna be using the Jupyter notebook, right? So for the other part of the problem, I think I'm gonna bring the whiteboard up. Again, some interview settings might not let you do this, but again, this is not just only an interview preparation step that I'm taking. It's moreover the learning part of the process, right? So I'm just gonna put these maybe over here, and we know that maybe I'm gonna move these a little more to here in case I have to read the problem. But we know we're gonna have an array of certain integers. I'm just gonna go ahead and take that first example we have there and try to fit it here and say that this array, probably gonna have to short it because I was able just to put 4 things in here. Let's just go ahead and add one more so we can have at least, so I'm gonna have 1, 1, 2, 2, and 3. Okay, that's fine for the sake of this example. And we have to, so k is gonna be equal to 2. That's supposed to be a k. I saw a video today of someone solving another problem for HackerRank. I think it was the between two sets. The problem, it was like a little bit of math in the problem, and the person made a k, and the k was like, mine's ugly, but we don't have to talk about this, but his k was something like that. Like, I looked like a signature, I don't know. And I was like, what? Anyways, that's why you saw me there struggling trying to make that K look better. I was just subconscious of that one. So here, we're gonna be iterating over the array, as I mentioned earlier. Kind of like the word of the problem. When every problem talks about frequency, or the frequency element, or counting numbers as part of an entity that repeat itself, where all that is kind of like frequency, and the way to approach frequency, at least for the most part, is using a hash table, right, or a hash map. Because okay, I gotta spell that right first. So the hash table basically is going to be a helpful data structure because it provides quick lookups, right? And that's one of the benefits of that. So we're gonna have, you know, key, and that key is gonna be associated with a value, and we can access to that value basically in constant time. And that's one of the benefits of a hash table. One of them. There are many, but for this problem, since we have to find the elements that are most frequent, I'm assuming from previous I don't know, experience, I've solved something similar to this problem, not necessarily a medium. I don't think I've done a lot of medium problems on LitCo. Kind of want to check that out. Would have to leave the. I think I would have to leave the thing, but I want to kind of check where I'm standing on LitCo. I'm not a LitCo fanatic. I'm not a LitCo expert. I haven't grinded too many questions. Yeah, I'm at 39, and I have 3 meetings and 36 easy. So, and this was March. This was like this is right before I got busy at work, and I was doing a bunch of stuff. But yeah, we're not here to talk about that. But I just wanted to kind of give you an overview of 82% acceptance. So even if they're easy, but hey, again, not self-shaming or anything. Just being realistic. It's a process and it's not easy, but it's a passion that we have to continue committing ourselves. You know, it's a career full of what's the word I'm trying to say? Paradigms. There you go. You can do it. But it's a career full of paradigms where, you know, people don't think they're smart enough, or maybe you don't have the capabilities to be a certain level. But hey, if you work hard on it, I'm sure we can do it. I'm sure we can get there. So let's just not give up. Let's just keep trying until we do it. There's no other way around. We're gonna do it. And that's the only way. The only way, at least for me, the only way. There's no turning back. So going back to hash table, fast lookup, we said it was a possibility. So this would be we're talking about my first approach, right? We're talking about first approach where we have a list of integers that's looking for the 2 elements that are most frequent in the whole array. So right off the get-go, we know we're going to have to look for every element in the array. So from the get-go, we know that we have at least a big O of n solution, right? Because we have to iterate over the whole data structure that is possibly very large. As we see here, the length of that array is possibly between 1 and 10 to the power of 5, right? So that could be considered as a large data structure or a large data set. So based on that, we know that our solution might be. So also here in the hint that we get over here, the follow-up, not a hint, but sometimes serves like a hint. It must be better than n log n, okay? So in the big O notation, if you know, n log n, it's going to be a little above, a little over on, right? So if we would have been log n, we know we're in good pace because it's under linear progression, right? Linear increment. But since it's n log n, we know we're going to have a logarithmic increase in our linear. Let me pull these up. Big O. Cheat sheet. There is going to be a cheat sheet. Pretty cool. No die complexities. If this thing would let me. Here we go. Yep. So yeah, this is what I was talking about, right? We have constant time, logarithmic time, which are the two best we can do. We have ON, which is basically our linear, what I was talking about, the progression. And then our solution, it's going to be the optimal solution for this is going to be n log n, which tell us we're going to be doing a few computations here, a few computations. That's why I'm a little I don't know, I can't find the words today, but resistant, I think is the word I'm trying to look for, because I'm seeing that I'm going to iterate over the whole array, and based on that I'm going to be adding these iterations to a table. So what I'm going to do is these numbers, once I start iterating over the array, these numbers will become the key of the hash table. So let's imagine this is going to be our hash table here. Let's just do it like this. And we're going to have the first key, it's going to be 1. The second key is going to be 2. And the third key is going to be 3, right? These are our 3 unique numbers here. So that's going to be our keys, right? We're trying to count how many times these numbers appear in the array. So we assign these numbers to the hash table right here, and we count them. So we know that if we see them 1 already, so if we are assigning their numbers to a key, we know that they're going to be at least 1, right? So let me go ahead and separate these. 2 and possibly 3. They won't repeat 3 times in this case, but that's possible. So 1 we see twice, so this is going to be equal to 2, or 1 here and then 1 here. Since they don't repeat anymore, I'm just going to go ahead and put here like a total or like a counter. So this is going to be equal to 2 in our final, these are iterations, right? This is our hash table. In the first pass, it counts 1. It counts 1. They all count 1 because as we add them, because we see them, we set their value to 1. In the second iteration, if they appear again, then we add another 1. So basically, this is acting like a counter. I know it looks kind of like a highway right now, I guess. But this is a counter. This is 1 and 1. So 1 appears twice, 2 appears twice, and this number right here doesn't appear twice. So it's going to be equal to 0 or nothing, right? But it only appears 1. So that would be our hash table, and we have the frequency. Now it's telling us to return this the two elements that are most frequent, right? If it would be one element, we would return the higher of these two, and it doesn't matter, I assume, because there are 2 elements, right? Just return one of them, but it's asking for 2, so both of these elements right here. Now, the way I'm organizing this example is very convenient because they're equal, 1 and 2, they are at the top. But a hash table, it's on order, meaning these frequencies can go anywhere. So we could have, I'm just going to go for the example we're making right now. I can have, or I can just move down here. I can have a hash table that looks something like this, in a sense of I'm going to have multiple numbers here. I'm going to have 3, I'm going to have 5, I'm going to have 6, I'm going to have 7, right? And I can have these numbers, I don't know, 3 could be equal to 1. So there's only one element 3 in that array. Let's say 5 is equal to 3. This was equal to 7, and this one is equal to 2, right? So we know this is not in order. right? And that's a problem in a hash table because, yeah, we can access these numbers in constant time, right? We can just call this key and in this hash table, right? Let me put table here, just, you know what kind of messy drawing I'm making here, but we could just call a key and it's going to be constant time, right? We're going to be able to pull that in constant time, right? It's going to, hey, we call for 6 and it's going to pop out 7. That's your value, right? Now, what happened is that we don't know. We can't just simply call, for instance, the Python has a built-in library, a built-in method called max, right? We can't call max on a hash table because we could call max and say, you know, max, give me the max of this table T, just define it like that. Give me max of this table T and give me the 2 max numbers. You could do that on an array. You can definitely do that on an array. I'm pretty sure, almost certain. You can say, you know, give me the max 2 numbers in this array. But what happened? We have a hash table because we're counting frequencies. So I'm not sure we can do that on a hash table. And I think that's where the next part of the problem comes in. You know, first we have to identify which data structure we're going to use to count the frequencies, but also it's how are we going to call these 2 numbers. Now we need, for instance, K2, or the most frequent 2 elements of this table, which is just a random example. So how are we going to pull that? If 6 is all the way down here, and 3 is all the way up here, right? Or in the middle. These 2 are in the middle. How do we pull that? So there's got to be a way where we organize that, and that could be part of the second problem. So my first problem is going to be probably first to remember how I count frequencies. So I know I iterate over the array, and I'm going to be iterating over that array, and based on that, I'm going to pull the elements out as I explain into a hash table. And then once I have the hash table, I have to count or find a way to pull out the 2 most frequent or the 3 most frequent or whatever number, right? K is equal to. So yeah, I think that could be a good approach. I think I can separate the problem in 2 parts. First, I'm going to count, not count, but first I'm going to, how would I say that? Add frequencies or find frequencies or hash frequencies. Anyways, I'm going to say like that. I'm going to hash elements. That's the first part of the problem. I'm going to hash the elements into a table, and the key is the element, the value is the amount of times that element appears in the table or in the array. And the second part of the problem would be to count those frequencies, or to not to count, to find the frequencies in the hash map. Find the frequencies, or yeah, I'm gonna say frequencies. I'm just gonna say F. And we can say F is a vector here, just for the, I don't know, sounds cooler. Why is it a vector? Because we need to know position, and we need to know position, and we need to know magnitude, right? And it's just, that's a vector. If it was just the magnitude, it doesn't matter, but we need to know where that element is in this table. So that's definitely adds the second part of complexity. So find the frequency in hash table. So that's for me. I think that's going to be hard enough. I could probably pick this apart and say, you know, loop through the array, count the numbers as they appear, add them to the hash map. Here I can say find f in the hash table. So I would, I gotta find a way, unless I need another data structure, right? But anyways, let's go ahead and take one of the examples, and let's say this is going to be our first approach, and let's go ahead and go into Jupyter Notebooks. I'm not going to go directly to code. I want to first find, let me go ahead and take this example right here, and I'm just going to go ahead and play with that until let me pass this function. Yeah, of course, list is not defined because they do this in Python on there, and it looks so good. That looks like Swift, the language, by the way, not the other Swift that everyone loves. Okay. Okay, I think I copied the wrong thing. Anyways, I'm just trying to get the example here and bring that over here, and actually I want to make that part of, I think I deleted K, so nums and K, and then I'm just gonna call that function with those parameters. For when I'm done coding, I have something to show. I haven't defined that function. There we go. So I'm going to say, right, I know I have to add elements to the table, or count elements, or add, just gonna say how I said earlier, hash elements to the hash table, right? And for that, I'm gonna say for every number in nums, it's already an array. It's an interval, so I can do that. And I'm going to say, actually I have to create the hash table. I'm going to say this table is going to be equal to frequent elements, or frequency counter. Okay, and it's going to be a dictionary or a hash map, whatever. You can do that this way, or I could probably say like dictionary like this. I think either or, they both have different ways to do it, but that's a way to do it. Let me just go ahead and let's go ahead and check frequency counter. I just want to print no, I'm good with that. I'm not gonna. So for every number in numbers, I'm going to say frequency counter n is equal to, for every number, let's see if I remember this, for every number in numbers, frequency counter at key k, a key of that number, it's equal to, it's going to be equal to 1. Or plus equal 1. Every number plus equal 1. And let me see. Again, I'm trying to remember how I used to do how I do this. It's been a while, and yeah, just part of the learning process. Carrier frequency plus equal 1. At that K, do I have to set it up at 1 first? Okay, yes. I can't add it. For every number in nums frequency counter equals 1, and then if I this might not be good, but I could say plus equal 1. Once we create it, I could say plus equal 1. Nope, because I'm not calling the key. Key n do plus equal 1. Okay, insert. I don't need insert right now. Here we go. 2, 2, 3, and 2. Okay, that's gonna work, but it's not gonna be that order of iteration, right? Because okay, I think I could fix that if I define the dictionary in a different way. Because what I'm doing is for every number I'm defining it here. I'm defining it here, but I'm setting every number as a key with 1, as I explained in the example. But we already know that there's going to be a... We already know that the first number, or yeah, we already know that the first number in here is going to be equal to 1. So I can come and say, if you see it again at another one, let's see. This is what I'm trying to say. If I already know that the first number in that, I could probably define it like this and say the dictionary and the first key is going to be nums. I'm not sure this is going to work. And then I'm saying, you know, create a dictionary with a key. I'm probably defining that. There's going to be at least one number there, so I could say there's going to be always at least one number there, so I could say that's the key and this is the value. I don't think that's, yeah, no, that's not going to work. So it's going to be contain assignment for argument equal. No. What I'm trying to do is to define the dictionary. Okay, I guess I could hard code that like this. Frequency frequency counter first key is going to be equal to nums at position 0, and well, I'm not assigning a value, and then I'm calling the counter. So nums at 0. Can I say nums at 0? Can I say nums at 0 and value 1? Okay. I could say that. Now here, instead of doing this, can I call this key error 2 frequency at n plus? No. See, that was the thing. I have to remember how to add a... I'm trying to add an element here that's already present. So I'm saying nums at 0. I know I need to do something like this, but then that becomes an array. Unless I... No. Nope. Anyways, I'm going back to square one and figuring out another way. So now I know that at least with that basic step, I'm adding every number at least once. For every number in num, so I'm iterating over every number and saying, you know, for 1, add it to here, and set up to 1 for every number in this array. I'm getting unique values, so I'm not getting key 1 1 1, right? That's a good thing about hash tables too, that it would keep unique keys. Now, how do I increase that counter? Because I'm saying for every number in nums, go ahead and add them. Let me see how that's working. There's something I'm not there's something I'm not seeing there that I definitely want to get a hold of, and obviously these are the ways that I figured out. Everyone has their own ways, but these are the ways I figured out how to find certain solutions and understand what's going on. Kind of like debug my own code so far. Call the list of array with that. Okay, frequency counter, I'm creating an empty dictionary. I'm saying for every number in the array of numbers, so n equals 1. Create that and add it to the list. Same thing. K equals 2, so okay, let me go back into dictionary. Okay, number equals 1. Equals 1, 2, 2, add 3. Okay. Yeah, we saw how the dictionary only cares about unique keys. So if we see once multiple times, it wouldn't count it. Now it's saying, you know, we saw those keys, I'm setting them to 1. Now what happened is that once I saw the key, I didn't add it. You know, and that's what I was trying to find out. It's like frequency counter. Once I see that, I want to go ahead and count it up. Plus, that's funny. But it's counting 3 twice. So that's I'm having a problem there, right? I'm definitely having a little issue there. But I want to see where am I going after that, right? Visualize execution, so we already know it's going to define all the elements. N equals 1, and then it counts 1 towards that. N equals 1, so it's setting it back to 1, and it's coming at 2. Okay. So after that, okay, I see what's happening. See, that's why it's important to do stuff like that, because I would definitely I'm setting up the first 2 once you leave. Yeah, once he gets out. So no, that's not going to be a way for me to update that, right? And then we said that if I say plus equal here, it won't be able to, because I'm trying to define a key that doesn't exist. So I need to find a way to add a key, the first key to this dictionary automatically, and then go from there. Nope. I'm trying to see if Shift tab. Nope. It won't help me here. Shift tab. Nope. So nums. Oh, I think I just remember. See, this is about thinking a little bit sometimes. Might not be right, but I think the way to add things here in this way to define dictionary is I can call nums of the first item of the array and then comma or comma whatever, and that's one, and that's gonna be spare more argument one got two. Nope, I was wrong. I'm trying to say that's the value of one, but the problem is that integer objects not iterable. Yeah, this is not gonna be the way for me to define the new empty dictionary. New empty dictionary initialized from a mappings object key value. Nums key value pairs. Iterable new dictionary initialize is as if b at d equal for k be in iterable. For num. Okay, I think I got a hint here, because key value in dictionary k equals that value. Yeah, I think I got hit there. So okay, all right, yes, I got it. I think I got it. Equals 1. And then I can say I can iterate for on that dictionary, say for key value in the frequency counter. Go ahead and make that key at right frequency. I have key and values. Go ahead and plus equal that value. Oh, defining this wrong up here. Cannot impact non-iterable object. For key and value frequency counter, I got a dictionary. Dictionary. What was I thinking there? Key value pairs. I can create the dictionary. New dictionary initialize have is wait a second. Can I say that my nums array is the iterable if I call this dictionary? And then add the at k equals value. Where's the dictionary? It's an iterable, so like it creates a new dictionary from that. Okay. I see what I'm doing. So let's see here. I'm trying to understand if I can Okay. Yeah, I just needed to kind of check that out real quick. So I guess I could always frequency counter is gonna be my dictionary. I guess it could always initialize that like this. For every num and num, set that equal to 1. What I'm missing here is I could say plus, instead of saying plus equal to 1, I could say plus frequency frequency counter dot get, right? And that would either set the value either at the value, right, if it's shift tab, that value n. So what I'm trying to say here is go through the array of numbers, go ahead and create that key and set it up to 1. If you see that key again, go ahead and add it, right, plus that key right here. And if not, just set a default value to 0. I could use that method there. I believe that would work. Instead of me saying frequency counter key plus equal 1, instead of me having to go through that array again, I think I could definitely, there we go. That looks better. So 1, it appears 3 times, 2 times, and 3 1 time. So that's what I need. Instead of doing plus equal 1, which is what I was trying to do, plus equal the value. If you see it again, I could just use the dictionary method here. You know, if you see that item for the first time, set it to 1. If you see it again, go ahead and add it. If not, set a default value to 0. Hope that makes sense. But yeah, I'm actually counting my frequencies now. I would say that's like the first part of it. What I'm thinking is also the second part, like I'm hashing the elements, right? That's the first part of the problem. We said that. I'm basically counting the frequency of the elements. But now for the second part, I need to find a way to get the frequencies of those numbers, right? Because here is organized from here's organized in descending order, right? Which is very convenient, right? But it's not necessarily always going to be like that. So I know at some point, let me just remove this. I know at some point I'm gonna need to print, because the problem says, if I'm not mistaken, so we're going to return output. We're going to be returning an array. So at some point I know I'm going to need an array, right? So I'm just going to say that this array of I guess the result equals that empty array. That is going to be after I find a way of basically sorting these elements. That's what I need, because I know conveniently that these inputs right now are organized in a way where 1 1 1. So for instance, I'm gonna switch that up so to make it more understandable, right? I'm just gonna put here final output, or I'm just gonna do output list. I'm just trying to break things in different steps so we got it organized. But what I'm trying to say is here, if the case would be this, which is, I think is pretty obvious right now, if we would have 3 being the number that repeats the most, like this, which I guess I could just keep it like that. I know it's not very Pythonic, but then everything changes. Then now starting at index 1, I don't have the highest frequency, right? 1 just repeats itself once, or the frequency of 1 is just 1 in this case, and now 3. And you could say, oh well, you can just start from the end, but we're working on a hash map here. And what I was thinking earlier is maybe mapping that hash map to an array, and kind of using some sort of sorting in that array where I can apply that. Maybe that could be a way to do that, but again, it's kind of like uncertain at that point. Let me see if I can get can I get the camera here? I don't think I can. No, I don't think I can get. Anyway, sorry about that. I was just trying to get my camera to. It's all good. Anyways, going back to the problem. So yeah, so I'm gonna need to find a way to sort this list here, and then pull from that list the top K frequent elements, because I'm trying to get the top K, right? So this could be equal to 3, this could be equal to, yeah, so I need a little more flexibility. So at this point, I think again, this is learning purposes. I'm not trying to crack any interview right now or do anything, but I think, if I'm not mistaken, I could use bucket sort, because it's going to sort it in the list in a way that I could. Let me just make sure I'm on the right track. Bucket sort. Let's refer you this rare solution. I guess I should go and check that over there. An index for each item. Once our elements are distributed into buckets, each bucket can be processed independently of each other. This means that you often need to sort much smaller arrays as follow-up step than the original array. Okay. Well, what I'm thinking is, I don't want to, and then just for the sake of the example here, I don't want to come here and say like sorted and then drop that array results there after. Obviously I would definitely do like result. Wait a second, can I create, I probably could use an array that that counts my frequency. I could use an array that sort my frequencies. That could be the array that I could use for it. And then sort it here, but that's, I'm trying to stay away from this, because again, the problem says something here. Time complexity must be better than n-log-n, right? So I'm trying to stay away from all the default sorting methods in Python, because I'm already going through the whole array here. So I'm already at big O of n, right? If I add a sort there, I would definitely, if I add a sort, a default sort, I'm very sure I would go to n-log-n, right? Being on my first array, and then going again through the other array and sorting that other array. Yeah. So what I'm thinking is maybe I could let's see here, just give me a minute. I'm trying to think because I already have my frequencies. I'm trying to see how I get those frequencies in my array. I guess I could say for numbers, for items and counts. So for, let's say, key and values, right? Just to go with the flow of the dictionary. So for key and values in would it be in my frequency counter? Would it be would it be I iterate over my dictionary and would it be, so okay, values frequency, I guess I could say frequency counter for the key and values in that frequency counter. And I want to iterate, this is a dictionary, so I could definitely use items for frequency counter dot items, right? And I'm iterating over the keys and the values. I could say, and I can see here how I could append these frequencies and values to here. So let's see. So for key and values in the frequency counter dot items, I could say, let's use that sort frequency, right? That sort frequency array and append. So I want to append the values that are higher, right? Oh, nice. It looks it's like a reassurance. That was myself actually, but hey, we'll take it. I could append well, how do I know? So let's say I have the key and the values, right? I could just iterate over the values if that I need is the values. I don't need the keys, but all right, I could just iterate. But how do I append? So I could append the values to here and then sort that, right? Again, I'm trying to stay away from sorting, but I'm gonna need some sort of sorting. That's what I thought for some reason. Bucket sort could be a solution because we could probably let me see here. We could probably have an array, right? This is the array what I'm trying to get my frequency values out of. So I can have an array here, right? And I could say, you know, index 1, index 2, index 3, index 4. That's trying to be a 4, but index 4. I'm trying to say, if the item at index 1 appears 3 times, go ahead and add it to the position 3 here. So let's say the item here is 1. 1 appears 3 times, or the frequency of 1 is 3. So we add that to the third index here, right? And I think this is the concept of bucket sort. And then let's say the second item is going to be 3. 3 appears one time. We go ahead and get 3 here. And then we had 5 that appears 4 times, right? So we go ahead and add 5 over here, and then we have, I don't know, 2 and appears twice, and so we put it here. So basically the position or the index of our array would be our counter, right? And we can return right? So 5 appear 4 times, 1 appear 3 times. So I would start from here and then go here if k is equal to, right? That's supposed to be k equals 2. So just bear with me on that one. So if k is equal to, I could get these 2 numbers. And I'm using the index here to count my frequencies, right? The only thing is that this array could be huge, right? So the problem I'm seeing here is that that array could be huge. And since I'm using the index of that array to count, if this array grows, let's say like I have 1,000 here, right? 1,000 only appears 1, so it'll come here. So what happens if I have multiple numbers that appear multiple times? So let's say like, yeah, 3 only appears 1, but 1,000 only appears 1. I would have to have a list in here with 3 and 1,000. And that's just 10, but I assume that's 1,000, or let's make it simpler and put 10 there, right? So I would have to make an array of arrays to use this method. And this list can be equal to the length of my input array, right? So for instance, I have 5 numbers here. So this is going to be of length 5, which this is I guess how this has nothing to do actually with the size of this array here I was looking at. I thought I was counting. So this is going to be equals 5. This looks like a mess now, but if I use an array of array and use the index as my counter, right? I could have multiple numbers, and then again starting from back here, I would just iterate over this array from the back to get the numbers that are in this array at the very end, and those are the numbers that have the most frequency, right? That makes sense on paper. So this should be an array of arrays, and here I would append the value. Right here, I want to append the value of, I have my key and I have my value. I want to append the value that is part of that array. So let's say I have key and value. The value is going to become my index, and I want to append the key to that index. So I got 65 numbers. So yeah, I want to pin what I want here. So, but I'm gonna need okay. So I would say a pin for key and value. Pin, the value becomes my index. The value becomes my index. So how would I append that value to a list of list? So I would, I know. Okay, I got it. I think so what I'm trying to say is I got the frequency, so I gotta say the value is my index. So at that index, go ahead and append that key, right? And that would definitely have the, yeah, because the value is the frequency. So we said 5 happened 4 times. We're not representing that here, but this is messy for the sake of the example. But like 5 repeats 4 times. So we took that value and make it our index. So that's what we're saying here. You know, at that index, which is the value, go ahead and append or item, and that's the item that would correspond to that specific index at that point in time, right? So from here, I guess I could organize this a little more. This is what's going on. This is what's going on. There we go. I'm matching the elements to the hash table here. Sorting. Here I'm sorting the elements. Sorting elements, right? And then all I need to do now is iterate over this array and add the items to the result. Now I need to keep in mind that k is going to be the factor that tells me how many items I have to add. So I could say for I could just say for noms or items, for items in this array, right? So I could say for the items in this array. No, I want to iterate over indexes. But I want to iterate from the back, right? So I don't want to iterate over the numbers, so I need to say for length and the length of sort frequency. I want to start from the end. Stop. I want to stop at the first item. So I'm starting at the end all the way to the first item. And I want to go one by one, right? So starting from the end, going to all the way to the first item, and I want to go by one. I believe that's how length it's gonna give it to me. Returns. Oop, nothing here, I guess. There's something. So do I have to slice? No. Starting from the end, going to the end. Oh, okay. I got to, since I'm coming from the end of the list, I have to go one by one, right? So, but what I'm missing here is this is what I'm missing here, because I'm like, what's going on? There's something, range length, range. So for every item in the range of the length of the list, starting, here we go, starting from the end, going to the first item, and so on, right? I don't want to repeat myself, but I got to kind of memorize that. Okay, so now I have to say, right, I have to keep in mind that K is the element that will tell me how many items I need. So if I could say if the length of the list, no, because the list is always going to be greater than not always, but the list could be greater than K, or most likely it's going to be greater than K. So I can't just say K for, I don't know. I need to think about this. The length of the list. Do I pop elements until I get to that part of the list, or do I pop elements from the end? No, from the beginning to get to the end, or do I? I got the list. I got the maximum element at that array. So I don't know. I think this is going to be, I'm not sure about this. Like, I know what I'm doing here, but also I don't feel like I'm iterating over every item, and I want to have an item okay. What do I need from this list? What I need from this list is the index, right? I need to go through the list and say, give me that index. Give me that the number that's at that index. So I'm not gonna. So for every item in the range of sorted frequency, which is my array that it's helping as an organizer, or like sorting my frequencies, I'm going to say for every number that is in at the index of that array, right? Sorted frequency at the index of that. So for every item in the range of that, starting from the end, go ahead and give me the number that starts at that specific item, right? And I get now why I was getting confused. This is a list of lists, and sometimes operate in these things, it could be confusing, because I see a bunch of for loops on top of each other, and I immediately get scared and think I'm doing something n square, but again, I'm not iterating over the same thing. I'm just grabbing that item from the first list, it's a list of lists, so I'm grabbing that item from that last index, okay? So I'm grabbing this item in the first iteration, I'm grabbing that item, In the second iteration, I'm grabbing this item. I guess I could make that look better. But that's what I'm doing here. Now here, I'm saying, go ahead and from that, at that index, give me that number, right? And we're going to add that number to if so, but I'm not counting K. I'm not counting K yet, because how many items am I gonna get? How many items am I gonna get from that list, you know? So if I say, for instance, if I say result dot append, if I append that number, how do I know result append that number? I'm gonna do some kind of dumb here. But actually, I gotta move these up here because I'm calling a list that it's defined outside of this scope. So I gotta come and do this here. But I'm going just to kind of see here. This might not be the best thing to do, but I want to see what I'm appending to that list, because I need to incorporate K here, and that's what I think. List index range start frequency for K and B. Append K. Interesting. So for key and value in frequency counter dot for every key and value in that frequency of items, I need to append that at that index. I need to append that value. Yeah. For key sorting items, I guess. Can I say return results? I know that's not going to change anything right now, but I'm just trying to bypass that. No. Frequency counter items. I'm trying to say for the key and the value in that dictionary, give me the. Oh, I guess I created the list after. I created the list after the list of list after I did that. Is that what that is? I was just trying to get what's going in results here. Like, how would I add results to that? You know, because I'm saying the key and the value of that, the key and the value in that in my dictionary, take that value and append it to that index that it's there in the list. So you know, that's why these meeting problems are a thing. This video is gonna go long ways, my friend. I'm not even sure that I'm going to be able to complete this on the same night. I'm probably gonna hopefully not. I'm not gonna say it. Okay. I could also say here that if I'm appending this value here, I could always check how big this array is, and if it's greater than 2 or k whatever at that moment, then so I could say if the length of this array, my result array, right, which is the one containing the values I'm trying to append, equals k, would I break here? No. Would I break and then come out and return return result? No, because this is just gonna break the loop. I guess I could just return result there. I guess I could just do that. I mean, I'm having a problem here. List index out of range that I have to solve before I go crazy there, but I'm trying to append, oops, sorry about that. I'm trying to append that value that I'm getting in my frequency counter. I'm trying to append that value, so I have the key, I have the value. I'm trying to append the value that I'm getting in my list of lists, right? So, oh, I get it. This, the list, I haven't set up a limit for this list. Remember? This list has to be the size of the length of my input. Look, because I'm appending something that's exactly out of range. Yeah, because this list right now technically doesn't have a size. You know, it's an empty list, and I'm trying to append something. Frequency counter, sort frequency. Yeah, the index runs out of range because I have more elements in my dictionary than in my list. Oh, come on, man. So I could say sort the frequency equals the length of nums. Probably. Could that be an option? Could that not be an option? I could say probably sort the frequency could be equal to the length of the array of nums, one being inclusive, right? But I don't want to do that in here because I want to keep that. So I could say for I could say, I guess I could do this, I for I in the length of nums. And then obviously inclusive because we want to go all the way to the end, right? So definitely there I could say that, and that would just give me the length of that array, right? The length of nums for every item that it's in, for every item in the length of nums, go ahead and open up a slot in frequency, right? Okay. See, I'm doing some room here. I'm saying for item in I fry in length of nums. I thought that's how you do it. Like if I even remove these from here, like if I go ahead and take this part from here, oops, not that part, not the whole thing, man. I guess I'm just trying to grab these. If I say I fry in the length of nums, would that create it? Or I could just say no. I could just say 4i in the length of nums. Same thing that happened to me down here. See down here? Range length of nums. I don't know why I'm always forgetting to use range. It's not that hard. Yeah. What am I missing now? I'm missing something. Sorry, restore the frequency. Range expected 3 Moscow 4. Oh. There we go. I don't know why I had a comma there, but anyways. 3, 2, and 1. K is equal to 2, so I just need to return 3 and 2. I'm returning 3, 2, and 1. So I'm missing something. I'm missing something here. Every item in the range length sort. That is correct. I'm adding these numbers. They're in the correct, order. That's what I care about. But the K is basically not working. If the length of that array is equal to K, then return it 3, 2, and 1. But K is equal to, so 3, 2, and 1. So K, basically I'm bypassing K right now. I'm good here. Result of the pin. I'm trying to pin here, so should I do the check after I pin, or should I do the check before? Because I'm saying for every number in that list, go ahead and append it. If that list is greater, then not greater. If it's equal to K, then return that. But it should return, K is equal to 2, so it should return 3 and 2 in this case, right? Let me grab this example from here. I know it's not going to change anything, just bear with me, because I want to have just a different thing to test. Just want to test something different, because I could grab the whole array. 1, 2, and 3. So 1 is the element, but I'm not getting K elements. I should return, in this case, I should return 1 and 2. So yeah, I mean, it's the logic is working. I'm just not returning and basically bypassing K. But for every item in the range, am I going through the whole thing without stopping in the last index, right? So I'm saying for every item in the range of length, sort my frequency from the end till the beginning at 1. Go ahead and give me that item, right? That number at that index, and append that number to my final list. If the length of that list equals k, then give me the results. There's something that I'm not looking at it. It's definitely here because it's gotta be here because I'm not let's go ahead and check. Let's go ahead and see what the test cases have to say, right? Because as long as we get can we format this? I thought this would format code. Yeah, I thought this would Is it come from here and format it? No. Anyways, I guess I'm gonna have to do this manually here. Why isn't formatting this thing? Oh, I guess I should select the whole thing. Alright, just bear with me here. I'm gonna have 4 spaces to everything because I guess I decided to come from Jupiter to here, but I would definitely thought that this would work. Formatting there, no, doesn't work. Doesn't want to work. Let's run this test case. It probably yeah, I'm getting 3 when I should return 1, 2. Again, I'm not cutting length of the frequency. I'm starting at the end till this number. We're going by 1 for every number and the sort of frequency. Append that number. If the length of my results are equal k, then return the results. For every numbers, the frequency counter equals 1 plus frequency counter get 0. That is correct. If I say for key and value in hit items append, so frequency counter for my items. Then add it to the frequency at that index. So key and value being the key, then for every item in the range of that frequency, -1 for every item in my dictionary, sort frequency, frequency counter, which is, and then frequency counter. I could say, no, I'm saying result does append that number, which is right. If the length of this equals, yeah, I don't know why is it going a third time. I don't know why it's going over a third time. Frequency at I, and in range, frequency at I. I mean, I literally, well, I'm getting this case right, which is 1, okay? But this is what's, it's going over one more time. Wait a second, do I need that array to be +1? Because maybe I'm going over that array one extra time and I don't need that. No, I mean, it's going to be out of range because it's inclusive, right? Okay. Well, that was the easiest one to pick out. But I definitely think here that I'm not so sure about this. I'm not so sure. I'm saying for every item in the range of the length of my list, starting from the end to the beginning, for every item in that array, for every number in that array, go ahead and append that number, right? This number, go ahead and append it. And if the length of the result equals k, then you just return that. But I'm going a third time over it. And I'm appending a third number. Could I say no, because I need that first number. Yeah. It's gonna return an empty list. I'm not going to stop starting from the beginning. So certain frequency plus, would it be +1? Would it be not inclusive? I'm getting a dumb error here. Just telling me, hey, what are you doing? For every item in the sort, for every item in the frequency, do I need to cap that frequency? That's inclusive. I guess I could visualize how that how that's working here. Remember, I started using earlier. This is the same example we actually have to fix, so I'm gonna keep it like that. Let's see what's going on here. Call these numbers. So we create our dictionary. We create our basically a list comprehension, but it's a list of list. and it goes by every item in that list. 2, 3, 4, 5, 6. Creates an empty list of list, right? We got a list with our empty list as we establish. And from there, we create our next empty list, and we start operating. So in our numbers, in our original array, the first number being equal to 1, we're going to say, hey, go ahead and add that number to our dictionary. Oh, I guess I can skip all that. Anyways, we were here. Yep. Go ahead and add that dictionary or that number to the dictionary and set the value to 1 because we already saw it, right? We already know that. Continue. We saw it a second time, so go ahead and add that counter. We saw it a third time. Perfect. We go to K2, which is the second value in the list. We do that. We do that. We know that. 3 and 1. We know that. Then we go ahead and there's an important step here. Then we go ahead and once we finish that, we go and check our frequency counter, which is our dictionary, and we say, hey, for the keys and values in our dictionary, which are 3 and number okay, key 1. Okay, here we go. I was confused. It's all the way up here, but k equals 1 and value equals 3. So this is our bucket sort, kind of, right? Where 3 is serving as 3 is going to be our index, and 1 is going to be or k is going to be our value. So since 1 is repeated 3 times, we're going to go ahead and put 1 in this empty list here at index 3. Perfect, and that's exactly what happened. We're going to go ahead and do the same thing with all the values. Since we only have 3 values, then we have 3 with 1 because 3 1 appear, or the frequency of 1 is 3. Same thing with 2, but 2 times, and 1 with 3 because its frequency is only 1. Okay, we know that. Now we go back and check our index or item in the starting from the back. Perfect. Okay, so we finished that. We have our bucket sort here. We have our dictionary that count our frequencies, and we have our extra data structures that are serving as plates, in this case, basically serving us different purposes, right? So we're going to go ahead and operate in that bucket list because we want to say, hey, for that item, starting from the end, so we're starting at the right point. Starting from the end, go ahead and check if that number so 6 for that number, insert the frequency of I, which is our list, and I would be 6 at index 6. So it's empty, right? It's going to go back up until it finds, so we see I change in here until it hits 3. It's empty, so it's not going to go and find anything when it hits until it hits 3, where it can iterate. Now it hits 3 or 3, as we can see here, and now it's going to say, okay, now what I do with 3, go ahead and append that to our result table, which is all the way down here, this empty list that we see here, right? And here it is. And then go ahead, go back up, and check if k, so we already appended here, and then check if the length of result equals k. No, k is equal to 3. This list is equal to 1. Goes back up and check for the sorted frequency. So I think that's where the problem is. Because it went back and check on that number, which is 3, which is the index, okay? So it goes back down, a is equal to 2. Definitely we have something at index 2. Append that 2 to our list, check if it's equal. And now it is. So the length of result at this point right here, line 18, the length of result, as we can see here, result is equal to k. So I don't know why it won't now just go ahead and it goes back up. If the length of result equals k, return result. It goes back up, and that's where pops 3 back in, because let me take this from here. 3 goes append 2. Okay, if the length of result equal k, goes back up. Sorting frequency I equals 2. Now I equals 1. So in 1 it's going to find 3, and that's where it's going to append it. But our list is already oh, is it because I have to do it outside the loop? Man, if that's the problem after all this time, no, it's doing the same thing. Because this is again going through the whole thing. So append. Should I break this loop after appending? No. Should I continue the loop after appending to force it to always check? To force, not here, but if I do this, to force it to always check before it goes up, doesn't sound optimal. Nope. I'm honestly running out of ideas here. Break. It would not work like that either. Okay. It's definitely taking an extra step right there. When it's like once you append 2 to it, okay, so here. So n became 2. And you're going to go ahead and append that number, which is in index 2 right here, to the list. In this check right here, this line that it's about to execute, as we see here, if the length of result equals k, k equals, why is k equal 3? That's what's happening. K is equal to 3. But why? When did k became 3? That's why it's continuing, because at some point I'm increasing the why am I increasing K? Oh, I'm using K here. Man, Jesus Christ, what a rookie. I mean, yes, I can't deny I'm a rookie, but also for let's just call this our index and value, and then go ahead and append that index. You know, you have to be patient in the process of coding, because that's why you can lose your head, to not say another thing. Because I mean, I've been using K the whole time, and I didn't think like it would have, but it definitely affects is if it's a parameter. I can't use a parameter. Anyways, at least we found that out, right? Yeah, I guess I could just have to change the index and the value here and append that here and run it, and it's definitely gonna work now, because we did everything so hard and then just a simple element. But that's, my friend, is that's what people talk about. That's what I hear all the time. People talk about like beats 49%. I'll be happy with that. Let's check if the complexity is what we were looking for. This is a cool feature. Upgrade to analyze more. Thank you. Anyways, we could say, right, so our space complexity is definitely going to be at least n, big O of n, because we are creating an array here of the size of the other array as we specify here. So that's fine. But we're going through the array of numbers here. Then here we are going to the other array. So still, up to this point, we are on a n square, big O of n, not n square. No, not n square. Up to this point, we are at on and speed, right? In our time complexity. Look at me. And then up to this point, we're good. So for the range, like sort frequency, so technically I'm iterating over this. I'm not iterating over this array twice, because here I'm declaring the array of the size of the array of numbers. So I iterate over numbers. I guess I'm iterating over nums twice. Here and here. And that would make it not so good. But also, I'm declaring the array here, and it's an array of arrays. So maybe not. I don't know, but I think we stay inside the constraint of n log n. It doesn't feel like an n log n, right? Especially using the little bucket sort trick, where we don't have to use sorted in Python. So I think that's a win. I think that'll be it for tonight. This video is extremely long, but hey, we learned something new. I definitely learned a lot from this problem. This is a hell of a problem. I'm happy there's no really math or physics involved, so I guess I'll stick with leak code more often. The problem was hard, but it's conceptually harder, not necessarily on a knowledge on a degree of knowledge, right? It's not, I didn't have to have any formula to solve this problem. I didn't have to have anything in particular, but programming knowledge, right? Data structures, bucket sort, and that's just something I recently learned based on other materials up here that I'll share later. But yeah, I think, I mean, that's, I'm happy. I'm happy. Let's celebrate. Let's celebrate. Let's get that confetti going. Let's go. And yeah, cool. We'll see each other on day 10, my friend.